So I'm trying just to give you a brief, description of what I mean by smart mobility and what have been done here. But I would like first to start with some not so fun facts, maybe, about transport and mobility. And I would like to start, with thinking that some statistics from this come from European statistics, that the average person in Europe spent something like 40 hours of its yearly life in traffic. And maybe that's not exactly the case in Finland. I think statistics for Finland is like 15, 20 hours, but in some cities this goes up to 150 hours. So now if you just think about your whole life, this is, 40 hours is a week of your work, active life that you are basically wasting, sitting on a car, braking and accelerating and so on and so forth. So quite much of time lost for you. And another interesting aspect to think about in this same field is that, while you are stuck in traffic, you are inside a essentially big machine of roughly 1 ton of weight, 4 or 5 meters in length and less than 2 meters wide. And typically, and the average occupancy of this huge machine is 1.3 persons for all the trips. And when you consider actually the most common trips that people do, which is work commuting trips, this goes down to 1.1 person. So each of these huge devices for moving one person back and forth our cities. This is quite a lot to think about. And the third fact is that the problem is not that we don't really have infrastructure. We actually do quite heavy and big infrastructure, but we are maybe just not using it efficiently enough. And some studies basically show that you can actually get up to 30% improvement in terms of these unnecessary delays if you just manage properly these kind of resources that we all have. Now, if we think about the great challenges that we are facing nowadays, of course, we think about climate change. That's what we are, I think, many of us are working to try to mitigate its effects. So if we think about how transport affects climate change, so these again are European statistics, but we clearly see that similar numbers are in other places in the world, sometimes even worse. But about 25% of greenhouse gas emissions come actually from transport. And out of these 25%, around 70% actually comes from road transportation. So at this point, one can actually think, well, but if I can actually get some improvement in how these resources, which are at the end common resources, are managed, we can actually really make an impact on the overall society and on the overall efforts against to combat climate change. Now, easy, not so easy. Actually, we are dealing with a very complex system here, right? So we're not talking about a complex machine, but we are talking about an even more complex socio-technical system, where we're actually thinking about humans and group of humans and society as a whole. And as we can think about, of course, when we are dealing with such complex system, we actually have, this means that we have a lot of small systems interacting with each other in very complex ways. And all these systems are actually moving at very different, with very different dynamics. So we have certain process which can be very fast. We can quickly change the signal plan of a traffic signal, but this actually has effects on the daily commuting patterns, and this has effects maybe in long-term decisions that actually people make. And a very simple, basic example that we have been knowing in our in transport engineering for many years is this, of course, this paradox of having a region or a road which is actually congested, and you do something to improve this congestion. Typically, you can build new lanes in the road. You can improve the management. You can improve traffic signal plans. You can build a tunnel, whatever. This will solve the problem in a well, immediate time. So in the next few days, everything will be solved. Maybe this will last a couple of months. But then this will actually attract more users to that road, which is now more attractive. And well, more car attracted, you get back in getting more traffic congestion. So you end up with the same problem that you actually had at the beginning. So individual solutions are not very useful at the end of the day. And if you think about what I basically describe is, and if you think about what, for example, US did in the last 50 years, just add more and more lanes and ending up with roads with 8, 10 lanes everywhere. Not very sustainable solution, and actually not a solution to any problem. So the way I think, the way I work on, the kind of problem I work is developing and designing integrated approaches for tackling with this problem, and thinking that these systems, these strategies need to be adaptive, and then aiming at the long-term sustainability of the whole system. So what we work on, so in my team, when we talk about smart mobility or intelligent transport systems, or different terms we actually may want to use, so we work in combination and intersection of different type of initiatives. One is, of course, the first one is about trying to optimize or to use in the best possible way the existing infrastructure. And this implies, of course, monitoring and optimization. And here as infrastructure, I think about the broadest possible term. So it's not only road, but it's also public transport system, services, and so on and so forth. But that alone, again, cannot be a solution. Otherwise, we end up with what I mentioned before. So together with that, we need also to think about travel demand management. So encouraging or finding some way so that we also can nudge, for example, people to use more sustainable modes, or nudge people to use in certain way the actual infrastructure that we have. And then, of course, in this, a role is played by future technologies. We are now hearing about automation, connectivity, and a lot of new mobility services, etc. And they will, of course, have a very big impact in the future. So how they're actually going to act at the intersection of the 2 points above. And then within my group, we basically work in both developing models, methods, more computational side, more at the level of implementation, experimental sides in these directions. And a couple of examples that I want to show here of what I mean, for example, by travel demand management. This is from a project that we did. And then we are continuing in this initiative. So, for example, having people try to understand how we can actually nudge people to choose a route which is not their favorite one, which is not their best ones. And so imagine that you're traveling from one place to another, and you have one best route, and you want some person to actually take a different route because it's better for society, based on some indicators that could be livability, which could be safety, could be emissions, anything else that we may actually think as a bigger goal than just bringing a person from point A to B. And our results actually show quite interesting that not every people are actually having exactly the same taste for the different possible nudges. Some people are reacting in different ways to the possible different nudging strategies that you can deliver to them. But this, of course, comes back to the point of having integrated demand management and personalized driving suggestion to users in order to allow them to make more informed and social relevant choices. When you, of course, think of, again, monitoring, managing such complex systems, we need data. You cannot escape from that, of course. And, of course, data comes with a lot of challenges. There is never complete data. That is always to have some gaps. And data is going to be incomplete. Data is going to have certain type of problems, and we can have new ways of collecting data. So another direction that we we have been exploring is also how to understand how all this data can be used for more informed, let's say, decisions, how this data can be gathered, how can this data be processed. So now, of course, nowadays, one of the hot words around is digital twins. We have been working on digital twins for quite some time. We just didn't call them digital twins. It was just monitoring and estimation in the past. But the idea is that, of course, we have all this data coming to our say, mobility management system at different layers. And maybe what we try nowadays is trying to better understand how the different layers are connected to each other. And of course, this data can come from services like crowdiness on public transport, and it can come from road sensors that you can actually, for example, monitor more accurately the road situation. And last topic here, maybe this is not the most comprehensive, but when we think about future technologies, there is, of course, huge hype about automated vehicles coming and resolving all our problems in our societies. That's unfortunately, I have to tell you, not going to be true. There is, of course, one big problem that we are all facing, the huge uncertainty of future scenarios. So we are going to witness a huge amount of different systems cooperating with each other, or at least coexisting with each other, maybe communicating with each other, but insofar there is not very clear one clear future path. But we have been investigating a lot how the different components may actually play together, and the answer is actually not very nicely. So in the last basically 10 years since I've been working on this field of automated vehicles, we started from the hype, automated vehicles will solve everything. And, well, I did my little contribution as well in understanding, well, no, that's not going to happen unless you don't manage them in a very appropriate way through appropriate coordination and cooperative strategies that can actually lead to true improvements in terms of efficiency and, again, long-term sustainability as the main goal. A brief wrap-up of what I wanted to tell you about here. When we think about mobility, managing traffic and transport systems, we cannot just focus on the short-term improvements, and isolated improvements, which I must say, this is what is mostly done by authorities and so on and so forth. But we need to think of long-term sustainability here. So thinking that the management strategy should be adaptive, so being able to adapt to all the different complexities and then interrelations that are taking place, and integrated as much as possible. So not just thinking of isolated optimization of one specific intersection in one specific area of the city or one specific mode, but we need to take them all into account, or at least all the effects into account, if we want to achieve this goal. Now, in here in particular, one point that I would like to stress is we cannot again focus on two aggregated metrics. So we have been for ages talking about we improve overall flows, we improve overall travel time, but we need to put more the focus on the travelers themselves. And one word that is getting more and more into my jargon now is seamlessness. So thinking of from the users, from a travel experience perspective, so that that travelers are actually aiming at these more seamless travel experiences. That's what can really nudge them towards more sustainable choices as well. And the last point I would like to bring here is that emerging technologies such as automation are definitely not necessarily the devil, but they are not also the solution by themselves. So they're just tools, in my opinion. They offer potential. They can bring to improvements, but also to unexpected effects. So to achieve progress, we still need cooperation and coordination again, thinking in terms of the whole complexity of the whole system. And this concludes my talk. Thank you very much.